Welcome to the AI Research Roundup. I'm Alex. Today we are looking at a paper from the Hugging Face trending list, published on November 14, 2025, about 6 days ago. It shows that by cleanly separating video perception from reasoning and training, the method reaches state-of-the-art results on 6 of 7 video benchmarks and gives roughly 2 to 9% gains over the base model. The paper is titled VIDEOP2R, Video Understanding from Perception to Reasoning. And as we will see later, the implications for how we train reasoning-heavy video models are pretty significant. Figure 1 illustrates why separating perception and reasoning matters for video question answering. The top panel shows a process-agnostic method that mixes the two steps, so one mistaken observation about the woman never turning back makes the entire answer wrong. The bottom panel shows a process-aware method, which treats perception as describing the video and reasoning as deciding the answer. Because perception and reasoning receive their own feedback, the model correctly notes that she paints, walks, then turns back, and it selects the right option. Figure 2 explains how VIDEOP2R trains video reasoning by splitting the workflow into perception, reasoning, and reward. The left side shows the two-stage pipeline, where supervised fine-tuning learns from process-aware chains of thought, and reinforcement learning further refines a policy model using process-aware rewards. The right side details the three-step chain of thought generation, which first creates observation and thinking text, then verifies format and quality, and finally checks whether the answer really follows from the perception alone. Figure 3 shows how the process-aware GRPO algorithm turns separate perception and reasoning steps into separate learning signals. The top panel depicts a video question with observation, think, and answer segments, which cleanly mark perception tokens and reasoning tokens. The lower pipeline then routes each group of tokens through its own reward block, so perception accuracy and reasoning accuracy, each shape only their respective advantages during reinforcement learning. Table 1 shows that process-aware training translates into consistently better scores across diverse video benchmarks. This table compares several 7 billion parameter video models, split into open-source baselines and reinforcement fine-tuned versions, built on the QN 2.5 visual language model. The blue bottom row for VIDEOP2R has the highest average accuracy, about 59, beating the previous best of about 57. This advantage holds across both video reasoning datasets and video understanding datasets, which suggests the perception plus reasoning separation generalizes rather than overfitting a single benchmark. Table 2 spells out why the full VIDEOP2R recipe is necessary for strong video reasoning. The top block shows that using both supervised fine-tuning and reinforcement learning together gives the highest average accuracy, beating either stage alone. The middle block compares process-aware and process-agnostic training, and the versions that separate perception and reasoning consistently win. The bottom block tests the reward design, where removing any reward term or dropping the separation of rewards always lowers performance compared with the complete setup. Figure 4 shows that stronger perception descriptions directly boost reasoning accuracy. A perception segment here means a textual summary of the video that lists key objects and actions in detail. When QN 2.5 visual language model only reads text plus VIDEOP2R perceptions, it already beats the raw video plus text baseline. In both the video plus text and text-only settings, prompts augmented with VIDEOP2R perceptions clearly outperform prompts using QN's own perceptions. Alright, to wrap up, the key idea is that treating perception and reasoning as separate processes with their own chains of thought and rewards gives cleaner learning signals and pushes video models to state-of-the-art performance. It also shows that strong textual perceptions can stand in for raw video more than many expected. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.